What can we do with the end-of-life photovoltaic panels? Is it possible to recover and reuse the silicon they contain? PARSIVAL project aims to answer these questions. PARSIVAL is a project financed by EIT Raw Materials, involving 9 partners among Europe. It focuses on Apulia in Italy and Extremadura in Spain, which are RIS, Regional Innovation Scheme regions, with a moderate level of innovation, characterized by an intensive installation of photovoltaic panels. The challenge of the project starts from the low of opportunities to reuse the photovoltaic panels and the lack of solutions for their end-of-life management. PV panels contain interesting metals such as aluminium, silver, copper and silicon. Some of them, such as copper and silicon metal, are critical raw materials for the European Union, but currently all silicon present in photovoltaic panels is landfilled. In the next 15 years, around 300,000 tons of photovoltaic waste are expected in Apulia and around 380,000 in Extremadura. How to deal with such huge quantities? One possibility is refurbishment. CEOA, the French Alternative Energies and Atomic Energy Commission, with Soren, the whole French community on photovoltaic, are agreeing on a procedure to qualify modules for a second life. This will be operated by the spin-off of the CEOA Solreed. The procedure comprises an optical inspection combined with electroluminescence analysis and a test in water. In addition, CEOA is sharing its knowledge with Regional Innovation Scheme local companies, such as Globeco. However, if a photovoltaic panel cannot be reused, recycling is mandatory in Europe. The startup Novetech has developed a process to recover and valorize the materials that photovoltaic panels contain. The innovative process comprises first mechanical removal of the aluminium frame and junction box, then thermal treatment to remove the encapsulant and backsheet, and finally mechanical separation of the materials and chemical treatment of the photovoltaic cells. This allows recovering aluminium, glass, copper ribbons, silver and the silicon-based photovoltaic cells. The issue is not only the recovery, but also the quality of the recovered metals, since low purity of the materials can compromise the reuse, in particular for silicon. Therefore, the project is finding different ways of recycling. University of Padova is studying its reuse in smelter through the production of silicon-based ferroalloy. At the same time, Enea, the Italian National Agency for New Technologies, Energy and Sustainable Economic Development, is developing a process for the silicon reduction to nanometric size and its application in batteries. The photovoltaic cells, eventually chemically treated, are milled to obtain a very fine powder. The powder is mixed with other materials and deposited on a copper plate to become the anode of a new lithium battery. Another approach for the application of the recovered silicon in batteries is the production of pure silicon anodes by the German startup Norxi. For this application, the silicon used by Norxi is previously refined by JPM Silicon and its spin-off Circular Silicon. Furthermore, JPM Silicon investigates the application of silicon in aluminium smelters, in the production of silanes for making new chemicals, and finally in the production of solar silicon. Erion, the largest extended producer responsibility organization in Italy, is performing a technical and economic feasibility study of a large factory for refurbishment, reusing and recycling photovoltaic panels. Gomez Pardo Foundation is doing the same analysis in Spain. In this context, it is necessary to educate professionals of the future to contribute to the generation of knowledge to address the lack of solutions for photovoltaic waste recycling. University of Salento is performing education activities to complement the previous ones, raising awareness on these industrial actions and strengthening the necessary social license to operate.